so this is your homework for tonight. Now these these problems are from 6-5. These are the actual problems from the textbook. That's why they start on number 11, not number 1. So you can actually check the back of the book as you're doing these for the odds that we don't do together. So just like we did with linear graphs, you know, the straight lines, y equals mx plus b, and quadratics, the first method of graphing anything is usually just a t-chart. So that's all we're doing today, is plugging in a bunch of numbers and seeing what kind of graph we get. Now, like we did in the past, hopefully from doing this several times you see patterns, and then you can start getting information without the actual graph. Kind of like, you know, you're able to get the vertex of a parabola without actually seeing the parabola, but we had a formula and a pattern. So same thing here. We're going to be mainly concerned with the zeros. Those are x-intercepts, the real zeros, and then the maxes and the mins. So know that, you know, these can curve up, they can curve down to any given place, so we want to find out what those are. So we're first going to do it from looking at the graph, but also going to show you patterns to look here at the y values, so you know how to get those values without actually graphing. So on the quizzes and tests, if you don't have the graph, you want to know how to get those zeros and how to get the min and max just by looking at the f of x column. Alright, now the calculator will be handy today. Some of your calculators just do basic calculations. You have to punch the whole thing in every single time. For those people, it might be easier just to do it the old-fashioned way. For some of you, like this one, it's a little bit more advanced, and you can actually plug in. Like if I want to plug in -5, I can store -5 as my variable, and then just type in the equation. Right, and that'll tell me, oh, it's 25. So I can get the same answer. And I don't have to worry about my graph being wrong simply because I make a arithmetic error in order of operations or something. No.
How much?
$17. Yeah. So if you've gotten anything more expensive than $17, $18 in the past month, know that this has probably cost less than that. So I mentioned this calculator at the beginning of the year, like this is a good one. Get one with a widescreen. It can do the fractions. And this is another thing it can do. It's a good investment. Some of yours, even if they have Casio, I believe, actually you can plug it in one time, and it'll give you the whole table. Right? So I'll walk around a little bit later and show those that have certain calculators how to use the functions. But yeah, the tool you have can affect how well you do a job. Sometimes having the right tool for the right job, it can be easier. And if that tool costs, you know, a few dollars more than what you have already, you have to, you know, weigh the benefits and the costs and see, well, what's worth it? Is it worth saving, you know, $3-4 or $17, or is an hour extra time doing calculations worth it just to go get a calculator that can do it for you? So on all these, I gave you the table, and I gave you the first point, and just count up by 1 all the way down to the bottom. So the step's always going to be 1 on these. We're not going to plug in any fractions. One, 2. So let's go ahead and calculate each one of these. Some of yours you can plug it in and just change the number like I did, change the value of x. Some of yours you just have to go back and replace both -5s with 2 -4s and just hit enter again. Some of you have to type everything every single time. It just depends on your tool. On mine, all I have to do is say, well, I want store -4 as x this time, and then go back up, hit it again, and I know the answer is 0. then I can store -3 as x. And then go back up, hit enter, and I get -9. Do that all the way down, and then verify your answers with somebody just to make sure. We don't want to start off by doing it wrong, so just verify your answers just to make sure. Okay, let's continue. Walked around, watched most of you. You did really good. Showed some of you that have a table function on your calculator, which is really useful.
Awesome.
So if you have a certain calculator, it'll actually on the screen show you a table of the x's and the f of x's on those Casio, I think 300s. Okay. So quite nice. So if you did all the calculations correct, here's what you got. Now we're going to have to make a decision on how to graph this. See? We're going to have to note that our graph only goes 8 in either direction. So if we're graphing up to 24, it might be difficult. But if you notice, except for the endpoints, it only goes up to like -9. So maybe we just count by 2's on the y-axis and keep the x-axis normal. So we can count by 2's. We won't be able to graph -5, 25, but -4, 0 would be, let's see, 1, 2, 3, 4. -3, -9. So we can go -3 right here, then 2, 4, 6, 8, 10. So it's between -8 and -10 right there in the middle. And then we have -1, -3. Is that correct? Okay. So -1 and -3 would be right here. And we have 0, 0. All right. 1, -5. So it goes back down. 1, -5. 2, 4, 6. So between -4 and -6. -2 and 8. Okay, forgot it. 2, 4, 6, 8 right there. Sorry about that. And 2, -24 just goes all the way down. So similar to the top. So how many turns does this graph have, knowing it's a third degree polynomial? 2, the other direction, yeah. So it's the number of turns plus 1 is the degree. So if we're going the other direction, yeah. We know it's a third degree. We know there's 2 turns. We know it's starting way up here because it's starting at -5, 25. So it's coming down here. Watch this. Here's 1 turn. Here's another turn. So you have to know, in general, what does a cubic function look like. It has to have 2 turns to know how to connect these dots. If you just randomly connect the dots in any order, it probably won't come out very good. Now, is this consistent with what an odd degree function looks like? Yeah, because one side's going up, one side's going down. So you can use a lot of indicators as you're doing this to say, well, this makes sense because, or this doesn't make sense because. So zeros, we're talking about x-intercepts. Yeah. So x equals 1, 2, 3, 4, -4. Okay. Also, you can see if you plug in -4, what do you get? A 0. That's why it's called the zeros. So the numbers you plug in that give you 0 are -4 and 0. As you can see, it's also an x-intercept. 0. Very fancy, lazy name made by mathematicians. What do we call those things when we plug it in and we get 0? Let's call them zeros. Okay. Let's go have lunch. Not thinking for one day. Now, here's a little fun fact. You know that there's 3 roots total because it's a third degree, and we only have 2. This one actually counts as 2 roots. It's called a double root because it doesn't go through the x-axis. So if you ever see it actually go up to the x-axis and turn right back around and not go through it, that actually counts as a double root. So there's really 3 roots that we're looking at. There's -4, 0, and 0. We had the same thing with parabolas. If we had a discriminant that equaled 0, we got 1 solution. We're really getting 2 of the same solution. We're getting 2 solutions, but the answer might have been 3 and 3. So we said, oh, there's just 1 answer. Technically, we were getting 2. They're just the same number. So we do have a total, I'm going to put an asterisk right here, of 3 roots. The reason I'm pointing this out is because the degree of that polynomial that we're working with, which is a 3, we have to have that many roots. So we have to have 3 roots. And it's impossible to have one imaginary. Imaginary or complex solutions always come in pairs, so we can't say, oh, it's -4, 0, and then maybe one's imaginary. That's impossible. Now, so again, we're looking at the x's. These are x values. That's important to note that these are x values. Just like we did with quadratics, these are all x values. Same thing with the relative max and relative min. We're only going to report the x values. We're not going to say, oh, like the vertex is at 2, 3. We're just going to say 2. Just the first value. So only be looking at the left and right of the mins and max. Don't be looking at up and down. So we're looking at the min. We can see right here is a min because it's going down, and it goes back up. So this is called a relative min since it's going down and it goes back up. It's the low point of this turn. So that's a min. And that occurs at approximately 1, 2, -3. So relative min, I'm going to say about approximately -3. It's approximately at -3. And the max, as you can see, it goes up and up and up and up and up, and then turns around right here at 0. Same place where the root was. So our max is at approximately 0. The reason I'm saying approximately is because we're doing this by looking at a graph. We can't assume anything. And we can't assume anything. Oh, it looks like it's 0. Maybe it's 0.9. We don't know. We'll find out next week how to actually get these precisely. But like we said before, we're always going to start by just looking at the graph. Okay. All right, so there's one problem. Okay. Kind of stretch it out a little bit longer. They'll get a little bit faster. Now here's something to think about. How can we get these answers right here in part B and part C without the graph? That's what you want to be thinking about. How can I get this same information but without having the graph in front of me just by using the table? Okay. So here's an insight. The zeros are kind of easy. Again, whatever you plug in a number and you get 0, yeah, that's the 0. So we can get the zeros pretty easily from the table, as long as we plug in the right numbers, of course. How can we get the max and the min just by looking at the table? Okay, so look at the behavior of the graph. The values of y are going down, 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 and then they start going back up. Right? Can you notice that in the table as well? Yeah. So it's going from 25 to 0, it's going down. It's going to -9, it's going down. And then what happens? It goes back up. So I can tell at -3, that's that low point. Without looking at the graph, I can tell just by looking at the table because the y values do the same thing that the graph does. They go down, 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 and then they shoot back up. Y values go down, 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 and then right when you see it turning around, that's when you go back up and say, oh, that's where it turned around. Same thing with the max. You can see here it goes from -9 to -8, it's going up, to -3, it's going up, to 0, it's going up, to -5, it went back down. So I can see here it turned around at 0. So it was going up, it was going up, it was going up, and then it turned around, went back down, went back down. So I can tell just by looking at the table that it turned around approximately at 0. I don't know if it's exactly 0. We can't tell. So that's why we're saying approximate signs here. So yeah, we can get the information but without the graph, but it's kind of good at the beginning to see both the table and the graph side by side. Helps make more sense out of all this. Okay, so let's start on number 12. If you haven't already. Regardless if you're using your calculator, fill out this whole table. And this time we don't need that last row. So we're going to go to negative 1, 0, fill everything out. Now 0 you get for free. You don't have to show any work on 0. I'm going to assume that you know that if you plug in 0, anything with a variable is 0 and you're left with a constant. That's also called the y-intercept, remember. The last number is the y-intercept. So 0, no need to show work. Okay, what do we get when we plug in negative 1? What did it come out to? Should get 3, hopefully. About 1. And here at 5, good. And 2, 6, and 3, and 4. 38, good. And once you see it really getting high or really low, that's how you kind of know to stop. All right. We all up to that point? Alright, good. Let's go ahead and graph it. So negative 2, negative 10. Again, I'm going to count by 2's. So I'm going to go negative 2, and then 2, 4, 6, 8, 10. Negative 1, positive 3. Negative 1, positive 3. 2, 4. Between 2 and 4 is 3. 0, 6, the y-intercept, 2, 4, 6. 1, 5, go down a little bit, so go down to 5. And 2, go back up to 6. So you kind of see that turn right there. And then 3 to 15, 2, 4, 6, 8, 10, 12. I lost it. 6, 8, 10, 12, 14, 15. I think that's right. Okay. And we know it's, again, a cubic, so one side is going to be real low, one side is going to be really high. Let's go ahead and sketch it. We're expecting 2 turns. I'm getting something looks like this. Right. Good. All right. Now the zero's here. What are the zeros here? Where's it across the x-axis? Alright, so you can see between here and here. Now we have no idea what decimal it is. We know it's a decimal, but we don't know a decimal. So for the zeros, we're just going to say, well, we're going to say what we know. It's between negative 2 and negative 1. That's all we know. Between these two numbers. Between negative 2 and negative 1. Now, how can you tell this without the graph, though? By looking at the chart. Yeah. So if the y values ever go from a negative to a positive, you know it had to cross 0 at some point in between those two numbers. Or if it went from a positive to negative. Because remember, all the positives are above, all the negatives are below. So anytime this switches signs from one number to another, you know that it crossed somewhere between those two x values. What about the max and the min? Yeah, we can tell, well, here's a max. It's going up, 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 goes back down. Here's a min. It's going down and goes back up. So the max and the min are like right next to each other. So we can say again, the max is going to be approximate just by looking at the graph. Approximately, by using our chart, so at negative 10, we go up to 3, we go up to 6, then we go back down. So it maxed out at 6, which would be the x value of 0. Remember, we're only reporting the x values. And the same thing here, at 6, it goes down to 5, but goes right back up. So that means if it is up higher, went down, went back up, that makes this the min at x equals 1, or approximately 1. And we can see the same thing on the graph. Yeah, right about 0, it looks like there's the first term that goes up. And then right at 1, there's about the second term that goes down. How many total roots are there on this? How many total altogether? There are 3. It's a third degree. There's 3 total. How many real roots are there? 1. Yeah, you can see right here, there's 1 time it crosses the x-axis. What does that mean about the other 2? What are they? Complex. Those are complex roots. And again, you notice how they come in pairs. I can only have 1 real root if I have 2 complex roots. Alright, good. 3 altogether. Alright, so that's how you're going to go through each and every one of these. Okay, you're halfway done. Remember to check 13 and 15. Check those in the back of the book. When you get to the back, you're going to have one that's to the 4th power. So that's going to have that W looking shape to it. So that's why we have to plug in even more values. Okay? And you have maybe up to 4 different zeros since it's a 4th degree. Okay. All right. Okay, you guys got about what, 8 minutes or so? Yeah, go ahead and work on another one of these. Check as you go. I'll help you if you need help with your calculator.